To effectively prepare for the electrical professional engineer exam, a systematic approach is essential. Firstly, begin by thoroughly reviewing the National Council of Examiners for Engineering and Surveying, or NCEES, exam specifications. This step is crucial for understanding the specific topics and the depth of knowledge required for each area covered in the exam. Acquainting yourself with these specifications ensures that your study efforts are well directed and aligned with the exam's content. Secondly, develop a structured study schedule. This schedule should allocate sufficient time for each subject area, allowing for a balanced and comprehensive review of all relevant topics. A well-organized schedule not only helps in managing time effectively but also ensures that no topic is overlooked. Thirdly, compile a collection of high-quality study materials. These materials should include prep books, practice exams, and online resources that closely align with the NCEES exam specifications. The quality of your study materials directly impacts your understanding and retention of the material, so choose resources that are reliable and well regarded. The electrical professional engineer exam heavily emphasizes practical problem-solving skills. Therefore, it is vital to dedicate a significant portion of your study time to solving problems, especially under timed conditions. This practice helps in developing both speed and accuracy, which are critical for success in the exam. Engaging in collaborative study can be highly beneficial. Joining a study group or working with experienced tutors provides opportunities to discuss complex concepts, share knowledge, and receive constructive feedback. This interaction can clarify doubts and enhance understanding through different perspectives. Use practice exams regularly to assess your progress. These exams help identify areas where you need further improvement and simulate the actual exam experience. Analyzing your performance on these exams provides valuable insights into your strengths and weaknesses. Thoroughly review relevant codes, standards, and design principles. Familiarity with these references is essential for answering many exam questions and is a key component of being a competent professional engineer. When selecting study materials, ensure they offer comprehensive coverage of all topics and concepts outlined in the NCEES exam specifications. The material should also provide clear and understandable explanations of technical concepts, making it easier to grasp complex ideas. The inclusion of ample practice problems with detailed solutions is crucial for reinforcing your understanding and improving your problem-solving abilities. Study materials should be up to date with the latest codes, standards, and industry practices to ensure that you are learning the most current and relevant information. Before committing to study materials, read reviews from past exam takers to gauge the quality and effectiveness of different resources. These reviews can provide valuable insights into the usefulness of the materials. On the day of the exam, arrive well prepared with all necessary materials, including a calculator, pencils, and reference materials. Having everything you need readily available reduces stress and allows you to focus on the exam. Effective time management is essential during the exam. Allocate your time wisely for each section and question to ensure that you can attempt all questions without rushing. Begin with questions you're most confident about to build momentum and boost your morale. Starting with familiar questions can help ease anxiety and get you into a positive mindset. Clearly document your thought process and calculations for each question to avoid deductions for incomplete answers. Sharing your work demonstrates your understanding and can earn you partial credit even if the final answer is incorrect. If you encounter a particularly difficult question, don't panic. Skip it and come back to it later when you have more time. Spending too much time on one question can jeopardize your ability to complete the rest of the exam. Stay hydrated by bringing a water bottle and taking short breaks as needed to maintain focus and avoid dehydration. Taking breaks can help refresh your mind and prevent burnout during the long exam. Confidence is crucial for exam performance. Believe in your preparation and abilities and approach the exam with a positive attitude. Trusting in your knowledge can help you perform at your best. The electrical professional engineer exam is designed to test your competence and knowledge. Don't be discouraged by the challenge. Preparing for the electrical professional engineer exam is a demanding process that requires a strategic approach and diligent effort. The exam is not merely a test of theoretical knowledge, but also of practical application and problem-solving skills. A well-structured study plan, comprehensive review of relevant materials, and effective test-taking strategies are essential for success. Begin by thoroughly understanding the scope and content of the exam. The NCEES publishes detailed specifications that outline the topics covered, the depth of knowledge required, and the format of the exam. This document serves as the foundation for your study plan. Allocate your study time based on the weightage of each topic in the exam specifications. Spend more time on areas where you are weaker or where the exam places greater emphasis. A balanced approach ensures that you are adequately prepared for all sections of the exam. Gather a wide range of study materials, including textbooks, reference manuals, practice exams, and online resources. Choose materials that are specifically designed for the electrical professional engineer exam and that are aligned with the NCEES specifications. Supplement your primary study materials with additional resources to gain a broader perspective and reinforce your understanding. Practice solving problems is paramount for success. The electrical professional engineer exam is heavily focused on practical application, so you must be proficient in applying theoretical concepts to real-world scenarios. Work through a large number of practice problems, covering all topics and difficulty levels. Solve problems under timed conditions to simulate the actual exam environment. Review your solutions carefully and identify areas where you made mistakes. Understand the underlying principles and concepts that govern each problem and learn from your errors. Consider joining a study group or enrolling in a review course. These resources provide structured learning, expert guidance, and opportunities to interact with peers. Study groups can be particularly helpful for discussing complex topics, sharing knowledge, and motivating each other. Review courses offer comprehensive coverage of the exam content, along with practice problems and test-taking strategies. Familiarize yourself with the relevant codes and standards that are referenced in the exam. The National Electrical Code, or NEC, is an essential reference for electrical engineers, and you should have a thorough understanding of its provisions. Other important codes and standards include those published by the Institute of Electrical and Electronics Engineers, or IEE, the American National Standards Institute, or ANSI, and the National Fire Protection Association, or NFPA. Take full-length practice exams under realistic conditions to assess your readiness for the exam. Simulate the exam environment as closely as possible, including the time limit, format, and difficulty level. Analyze your performance and practice exams to identify your strengths and weaknesses. Use this information to refine your study plan and focus on areas where you need further improvement. Develop effective test-taking strategies to maximize your score on the exam. Read each question carefully and understand what is being asked before attempting to answer it. Manage your time wisely and allocate a reasonable amount of time to each question. Eliminate obviously incorrect answer choices to narrow down your options. If you are unsure of the answer to a question, make an educated guess and move on. Don't spend too much time on any one question, as this could jeopardize your ability to complete the rest of the exam. Arrive at the exam center well rested and prepared. Get a good night's sleep before the exam and eat a healthy breakfast. Bring all necessary materials, including your calculator, pencils, erasers, and reference materials. Dress comfortably and bring a sweater or jacket in case the exam room is cold. Stay calm and focused during the exam. Don't let anxiety or stress overwhelm you. Take deep breaths and remind yourself that you are well prepared. Read each question carefully and try to answer it to the best of your ability. If you encounter a difficult question, don't get discouraged. Skip it and come back to it later. Stay positive and maintain a confident attitude throughout the exam. Some extra additional tips to remember are: firstly, know the exam format, which consists of multiple choice questions that assess your knowledge and application of electrical engineering principles. Secondly, manage your time effectively. Allocate time for each question and stick to your schedule to avoid running out of time. Thirdly, read each question carefully. Understand what is being asked before attempting to answer. Fourthly, eliminate the correct answers. Narrow down your choices to increase your odds of selecting the correct answer. Fifthly, use your resources wisely. Familiarize yourself with the reference handbook and other permitted materials. Sixthly, practice, practice, practice. Solve as many practice problems as possible to reinforce your understanding. Seventhly, stay calm and focused. Maintain a positive attitude and manage your stress levels during the exam. Eighthly, review your answers. Double-check your work and ensure that you have answered all questions accurately. The Electrical Professional Engineer exam assesses a wide range of topics within electrical engineering. These topics include power systems, including generation, transmission, distribution, and protection. Secondly, electronics, including analog and digital circuits, microelectronics, and signal processing. Thirdly, control systems, including feedback control, stability analysis, and system modeling. Fourthly, communications, including modulation, coding, and wireless communication. Fifthly, computer engineering, including computer architecture, embedded systems, and software engineering. Sixthly, instrumentation, including sensors, transducers, and data acquisition systems. Seventhly, electrical safety, including the National Electrical Code, or NEC, and other safety standards. To prepare for the Electrical Professional Engineer exam, candidates should focus on several key areas. Firstly, review fundamental concepts, including circuit analysis, electromagnetics, and power electronics. Secondly, practice problem solving. Solve a wide variety of problems to reinforce your understanding and improve your problem-solving skills. Thirdly, understand the code. Become familiar with the National Electrical Code, or NEC, and other relevant codes and standards. Fourthly, use practice exams. Take practice exams to simulate the exam environment and assess your readiness. Fifthly, seek guidance. Consider joining a study group or taking a review course to get expert guidance and support. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. Several key areas within the National Electrical Code, or NEC, are important for electrical engineers to understand. Firstly, general requirements. Chapter 1 of the National Electrical Code, or NEC, covers general requirements for electrical installations, including wiring methods, overcurrent protection, and grounding. Secondly, wiring and protection. Chapter 2 of the National Electrical Code, or NEC, covers wiring methods and materials, as well as overcurrent protection for conductors and equipment. Thirdly, equipment for general use. Chapter 3 of the National Electrical Code, or NEC, covers equipment for general use, such as switches, receptacles, and lighting fixtures. Fourthly, special occupancies. Chapter 5 of the National Electrical Code, or NEC, covers special occupancies, such as hazardous locations, healthcare facilities, and recreational vehicles. Fifthly, special equipment. Chapter 6 of the National Electrical Code, or NEC, covers special equipment, such as elevators, electric signs, and swimming pools. Sixthly, special conditions. Chapter 7 of the National Electrical Code, or NEC, covers special conditions such as emergency systems, standby power systems, and fire alarm systems. Seventhly, communications systems. Chapter 8 of the National Electrical Code, or NEC, covers communication systems such as telephone, cable television, and data communication systems. When solving problems related to the National Electrical Code, or NEC, it is important to follow a systematic approach. Firstly, identify the scope. Determine which sections of the National Electrical Code, or NEC, apply to the specific situation. Secondly, review definitions. Understand the definitions of key terms and concepts used in the National Electrical Code, or NEC. Thirdly, apply the rules. Apply the rules and requirements of the National Electrical Code, or NEC, to the specific situation. Fourthly, verify compliance. Ensure that the electrical installation complies with all applicable requirements of the National Electrical Code, or NEC. The Electrical Professional Engineer exam requires a deep understanding of various electrical engineering principles and their practical applications. Candidates should dedicate ample time to mastering these concepts and honing their problem-solving skills. The following list consists of key formulas and equations frequently used in electrical engineering, which are particularly relevant for the Electrical Professional Engineer exam. Firstly, Ohm's law, which relates voltage, current, and resistance in a circuit. Volts equals current times resistance, or volts equals amps times ohms. Secondly, power formula. Power, measured in watts, is calculated using volts times current, or current squared times resistance, or volts squared divided by resistance. Thirdly, Kirchhoff's current law, which states that the total current entering a junction is equal to the total current leaving the junction. The sum of currents in equals the sum of currents out. Fourthly, Kirchhoff's voltage law, which states that the algebraic sum of the voltages in any closed loop is equal to zero. The sum of voltages equals zero. Fifthly, impedance in AC circuits. Impedance is the total opposition to current flow in an alternating current circuit, comprising resistance and reactance. Z equals the square root of resistance squared plus reactance squared. Sixthly, power factor, which is the ratio of real power to apparent power in an alternating current circuit. It indicates how effectively electrical power is being used. Power factor equals real power divided by apparent power. Seventhly, transformer turns ratio, which relates the number of turns in the primary and secondary windings of a transformer to the voltages and currents. Volts primary divided by volts secondary equals turns primary divided by turns secondary equals current secondary divided by current primary. Eighthly, diode equation, which describes the current through a diode as a function of voltage and temperature. I equals I sub s times the quantity of e to the power of volts divided by nVt minus 1, where I sub s is the saturation current, volts is the applied voltage, n is the ideality factor, and volts sub T is the thermal voltage. Ninthly, bipolar junction transistor, or BJT, current relationships, which describe the relationships between the base collector and emitter currents in a bipolar junction transistor, or BJT. I sub C equals beta times I sub B, and I sub E equals I sub C plus I sub B, where I sub C is the collector current, I sub B is the base current, I sub E is the emitter current, and beta is the current gain. Tenthly, operational amplifier gain, which is used to calculate the gain of an operational amplifier, or op-amp, in different configurations such as inverting, non-inverting, and differential amplifiers. The gain is volts out divided by volts in. 11thly, Boolean algebra, which is used to simplify digital logic circuits. Examples of Boolean algebra are A and B, O, B, and not. 12thly, sampling theorem, which states that a signal must be sampled at a rate at least twice its highest frequency component to avoid aliasing. F sub s is greater than or equal to 2f sub max, where f sub s is the sampling frequency and f sub max is the maximum frequency component. 13thly, Shannon's channel capacity, which gives the maximum rate at which information can be reliably transmitted over a communication channel. C equals B log base 2 of 1 plus S divided by N, where C is the channel capacity, B is the bandwidth, S is the signal power, and N is the noise power. 14thly, antenna gain, which measures the ability of an antenna to focus radio frequency energy in a particular direction. Gain equals 4 pi times effective area divided by lambda squared, where effective area is the antenna's effective area and lambda is the wavelength. 15thly, decibels, which are used to express ratios of power, voltage, or current on a logarithmic scale. Decibels equals 10 log base 10 of P2 divided by 0 equals 20 log base 10 of volts 2 divided by volts 1 equals 20 log base 10 of current 2 divided by current 1. In addition to formulas, understanding key electrical engineering concepts is crucial. These concepts are essential for solving complex problems and making informed decisions in practical applications. Firstly, circuit analysis, which involves the study of electrical circuits to determine voltage, current, and power. Secondly, electromagnetics, which is the study of electric and magnetic fields and their interactions. Thirdly, power electronics, which deals with the conversion and control of electrical power. Fourthly, control systems, which focuses on the design and analysis of systems that regulate and control the behavior of other systems. Fifthly, digital logic, which is the foundation of digital circuits and computer systems. Sixthly, communications, which involves the transmission and reception of information using electrical signals. Seventhly, signal processing, which deals with the analysis, modification, and synthesis of signals. Eighthly, instrumentation, which involves the measurement and control of physical quantities. Ninthly, electrical safety, which focuses on the safe design, installation, and operation of electrical systems. Preparing for the electrical professional engineer exam requires a comprehensive understanding of electrical engineering principles, proficiency in problem solving, and familiarity with relevant codes and standards. By following a structured study plan, utilizing quality study materials, and practicing consistently, candidates can increase their chances of success on the exam.